This is a bit of a demo of the final tool I built as part of my research work, which was basically an activity recognition tool in a smart home. This is the culmination of what was essentially a multi-stage classification process. What this tool essentially tries to do is to tell you what devices are connected in your network. And it does this in a human-readable form. So the very premise of this tool is to be a user-friendly tool. So in a sense, it tells you what is the volume of traffic in your network, then what are the IP addresses in your network, and what are the human readable names. So if you have a specific IP address, would that be a Hue bulb? Would that be a metal? Would that be an Alexa Eco Studio, and so on? But it goes on to essentially tell you the state of these devices. And in a way, it is a bit of it takes a different approach than other common diagnostics tools like Home Assistant and OpenHab, where this tells you all of these things automatically. And it does this through a set of pre-trained, supervised learning classifiers, which have been trained on data sets taken from network traffic. So that's the deviation from current tools, which you need to connect your smartphone app to a specific tool, and the tool retrieves data from the cloud version of that smartphone app. Essentially, like that's what happens with SmartThings and Alexa and Nest. So this tool basically tries to avoid that. So in a sense, it's basically like a diagnostics tool in a way. So with the front page itself, it's designed to be super simple, where let's say you have a bunch of a bunch of devices, and you have a bunch of rooms, and all you want to know is which rooms are active at the moment. So what this tool tells you is 5 rooms are active at the moment, the hallway, the study, living room, bedroom, and kitchen. It also tells you that the bathroom's inactive, and there's 2 bathroom signs here, but that's basically because there are two bathrooms, and there are devices in both bathrooms that are inactive. And then also it quite simply maps this to an activity. So the rule here is if 2 or more devices in a room are active, it basically says, okay, there's something happening there. So for instance, the kitchen. Suppose there's a kettle active, and there is, say, a smart stove or a fridge active, or even a door active. So let's say a door has been opened and closed. It'll assume that you're cooking or doing something of that effect. Same way for study. If there is a bulb active, or maybe even your laptop active, it'll say you're working. So it tries to give you all of this in one glance without overwhelming you. What it also does on this page is it gives you a bit of an insight into the warnings. So suppose you have a bunch of devices that are, well, they have been on for a while. It tells you that anything beyond 12 hours might be a bit of a mistake, as in it could be that there's a problem with the device itself, or there's a problem with the tool. So in this case, it basically says a specific device. Here it's classified it as a weekend kettle with IP address so-and-so has been on for 16 days. So it does this because it retrieves all of this data from its database. And then it also tells you to check your energy savings. So this is just a bunch of warnings it gives you. It also tells you any sort of any physical anomaly, basically. This is not a cyber anomaly, a physical sort of warning, really, that a set of devices might have been activated in the late hours of the night. So in that case, it basically says, say, device Alexa Eco Studio was active at 1:28 in the night. This is just basically just insight into what's happening late at night, and these can be changed based on rules. So that's a very simple take on insights in this tool. It goes on to give you a bit more of insight into your connected devices. So it does this through a complete overview of your connected devices here, and a basic overview of your historical data. So within connected devices, that's where the sort of the magic of the 3 classifiers takes place. So because this is a multi-stage classification process where A set of classifiers are basically trying to gauge what devices are connected in your house and what their current states are and what their names might be through fingerprinting. The output of that is basically very simply output into this FLAS table. It goes on to give you more of a diagnostics capability. So it basically tells you which devices are IoT or not, then what are the responses to an ARP address resolution protocol call. So it does that as well. And then it also lets you input certain things. So apart from device name and device action, which is written here, I'll show you this page in further detail, but I just wanted to give an overview here itself. It also has location. So within location, users can basically input the last known location of a specific device. And that may change in future, but the tool has a database, SQLite database, that basically this label gets sent to. It has a more sort of major, it has a more specific intent for that labeling, which I'll come to in a bit. And that's a brief overview of what this page does anyway. The historical data page, on the other hand, is quite simple. So all it does is it retrieves the states of all your devices, because what it's done is it's stored all of these states in a table. And in a way, this is scalable because it just stores 5 values in a table. And it does this for a certain amount of time before deleting itself. So it's not really storing PCAPs, which can be easily 3 GB or so a day if you have more than 10 devices. It's doing this in a far sort of less memory intensive manner. So anyway, this is the connected devices page. And what this is doing is, as I mentioned, it's basically sort of assessing all of the IP addresses under a private range. So the range I've chosen is 192.168. There might be others. There's a 10.0 as well. That can be reprogrammed to basically assess that. But this is quite a common private address range, which is why I've chosen it. So it basically looks at all the devices through a tool called T-Shark, which is the command line equivalent of Wireshark. And there's a background process, a sniffing process, which is happening every 30 seconds, where it is collecting packets indiscriminately for 30 seconds. And it's doing 2 things to these packets. It's parsing it to a header metadata file. So it's a CSV file. And the second thing it's doing is it's converting it to flows. And those flows are parsed and automatically converted to a set of features or set of columns. And these 2 CSV files form the input for 3 classifiers. So the packet file forms the input for the IoT versus non-IoT detection, which happens a bit further down. That's here. So what happens is that file, one of its features, or rather one of its labels, is the source IP itself, and it's able to detect quite simply from a 91 feature strong data set, whether it's a non-IoT or an IoT device. So it's been trained extensively with label data. And what it's doing here is it's giving a probability score. And it's basically saying it's got quite a high probability that this is not an IoT device. And conversely for this, it thinks it's an IoT device. Though, of course, this can be rechecked. And I think a limitation of this tool is it requires further analysis in the wild as such. So it does do this, but the reason this table is quite low down is because this may not be the first priority of someone looking at this tool. The first priority really is something else. But while I'm at it, the second sort of niche thing this does is it sends out ARP requests. And any device that answers the ARP request, basically that the MAC address is also recorded for the device. And this happens every 30 seconds, just to see what devices are active in your network. So these 2 are really more of a niche thing to see within this page. But the main real purpose here is it gives you a complete list of all unique IP addresses and the latest states of all these unique IP addresses ever recorded. So in this particular set, it goes on for I believe 15 days or so. So the latest right now is one at 8:38, and it's currently 8:39 in the night. And it's basically saying that there is an Alexa Eco Studio in the house, and it is on, and it's in the living room. So the way it found out that this is an Alexa Eco Studio is because this was a multi-class classifier that basically was labeled on 8 devices from the Smart Home Lab. And it basically has what is labeled on a set of flows. So these were 30-second flows. So how these flows were created was, if a PCAP, once you captured a PCAP file, they were cut using edit cap to a set of 30-second packet captures, and these were converted to flows, and that was converted to what was a different feature set. So about 83 features. Those were basically like packet-based statistics, like how much flow, what are the packets sent in the forward direction, packet length sent in the backward direction, basic statistics like that, mean, variance, and all of that. So that was automatically generated by this tool called CIC Flow Meter. And it was sort of, I think it has scope for further training, for further customizing that feature set. But that was the de facto feature set was what was used here. And it basically tells you, well, that the device is off right now. So this was a different classifier, a binary classifier. I believe it was Light GPM that was trained. And these were again trained on a flow-based data set with, I think, a bunch of devices. But then the sort of the training data for this was quite was far more extensive. In this case, the off values were basically captured for 2 or more hours, because there are certain patterns that that sort of come through in traffic when the device is off. The on values, basically, there are patterns in traffic when a device is on, but then it's quite, in a way, there are bursts of data, but off is a bit more predictable for each device, where it's, if you keep recording the traffic of a specific device, like a Philips Hue bulb, you'll notice that it sends specific packets at specific intervals of a specific length. On may be a bit more variable. So that's essentially what this classifier does. The third one, device location, is not a classifier. It's basically just a function within Flask. So all of this are inputs that I created. So a user has the opportunity to put in the location of a device, and then that goes into the database, and that gets retrieved onto the table in the next 30 seconds. And then what happens is the database is automatically corrected. So so any device with this IP, it remembers that this is the location for it. And this is useful. This tag is very useful for, for analyzing if there's a specific activity happening. For example, if you have a bulb in the kitchen, that might mean you're cooking, but a bulb in the study might mean you're working. So this is quite an important label itself. The second label that this has is the device name label. So in a way, you can also sort of, any unknown variable here. So the classifier does output an unknown label, and it does so on the logic that anything under a 90% accuracy value, probability score really, is labeled as unknown. So the user has the opportunity to go ahead and say, this specific device is, for example, say a Lumiman bulb. And you can submit that. It doesn't automatically get submitted. It sort of goes into the database, and in 30 seconds, it comes back up. But the more important thing that's happening is this is used as a supervised form of learning. So since I've input the name of this specific IP address, it'll go back in time to about 3 days worth of packet captures. So not 3 days worth of packet captures, 3 days worth of flows. So that's much lesser size, memory size than packet captures. And it tries to annotate all the IP addresses of this with LumiMan bulb. And that will eventually serve as training data for a multi-class classifier, for the device classifier, so the device fingerprinting classifier. And in future, if a guest comes and for some reason the guest were to bring a bulb, it might classify that as a LumiMan bulb. Now, this has not been tested in this dissertation. I have not tested it with these with a LumiMan bulb, or tested a new bulb coming into the system. So I think there's immense scope for testing out the online training capabilities. So that there's future scope for that, sorry. But yes, in a sense, that's what this page does. The other page really is a dashboard. So it might take a bit of time to load, but what the dashboard does is it gives you basically a lot of historic data of all your device states. So it's right now programmed to give you 23 point, almost 24 hours worth of data. But you can change this. You can change this time period. And it gives you a 1 value, which is on, and a 0 value, which is off. So you can kind of see trends of what your devices are doing. And in a way, this tells me that there's this one specific device that either the device has been acting strangely or the stool is not functioning correctly. Because there's quite a few on or offs happening quite quickly. So it could very well be that the classification is not working in this case, because it's trying to, every 30 seconds, predict if that specific device is on or off. And in certain cases, an on device, like a bulb, might not really transmit something in 30 seconds. So it will act like an off device. So there are limitations where I think the capture period can be longer than 30 seconds, maybe a minute or so, for it to actually gauge what the true state of the device is. So 30 seconds was chosen because this tool is trying to be real time or almost real time. But yes, there is definite, I think most surely that there has to be a little more experimentation where maybe 45 seconds might be the optimal mark. Maybe 60 seconds might be it. Research papers said that 10 seconds also might work. So there was an allied research paper that I looked at, which dealt with privacy. It didn't deal with user activity. It just tried to see exposure. So it said it is possible to detect differences, but the range of those differences was not really outlined in that paper. So I think there is scope for future work to find out what the optimal amount of time period is for a classifier to gauge whether a device is on or off. So I've just tried to input the 9th of October, so from the 5th to the 9th. See, I think, so certain devices were not really on till then. So I mean, not really active in the network till then. But yeah, what it's essentially doing is it's trying to get you all the way till there. So yeah, you can see changes in trends for any device, even historic. So it'll end on the 6th of November, if that's when you disconnected the device from the October, sorry, if that's when you disconnected the device from the network. So yeah, so this is basically the tool. Thank you very much for listening. Thanks.